Quick, what's the difference between ChatGPT and an AI agent? If you said agents can take actions, you're half right. But here's what nobody tells you. There are actually 7 completely different types of AI agents, and the one you pick determines whether your app is a toy or a product. By the end of this video, you'll know all 7, you'll see real code for each one, and you'll have this. Before we dive into the 7 types, let's nail down what actually makes something an agent. Because calling every chatbot an agent is like calling every Python script an app. An AI agent has 3 core components. First, an environment. That's the world the agent operates in. Could be your file system, a database, the internet, or all 3. Second, sensors. That's how it perceives the environment. Reading files, parsing API responses, analyzing user messages. Third, actuators. That's how it acts on the environment. Writing code, calling APIs, sending messages, clicking buttons. Here's the key insight. A chatbot only has sensors. It reads your message and responds. An agent has sensors and actuators. It reads your message, makes a plan, and then does something in the real world. That's the line. And every type we're about to see draws that line differently. Type 1. Simple reflex agents. These are the if this then that of AI. No memory, no planning, no learning. They see a condition, they fire a rule. That's it. Think of your email spam filter. It sees the word lottery in the subject line? Trash. It doesn't remember the last 100 emails it filtered. It doesn't learn from your behavior. It just matches patterns and acts. In code, it looks exactly like you'd expect. A condition and a response. Simple. In the real world, ESLint is a simple reflex agent. It sees a rule violation, it flags it. GitHub Actions running on push, simple reflex. Even most chatbots before 2024 were basically this. Pattern match the user's input, spit out a canned response. The strength, speed, and reliability. The weakness, they're completely blind to anything outside their rules. If a situation isn't in the rulebook, they freeze. Type 2. Model-based reflex agents. Same idea, but now the agent has a mental model of the world. It doesn't just react to what it sees right now, it tracks how the world is changing over time. Think of a thermostat. Not the dumb kind that just checks is it cold. A smart thermostat. It knows the current temperature, but it also models how fast the house is cooling when you usually come home, what the weather forecast says. It builds an internal state, a picture of the world, and makes decisions based on that picture. In the developer world, this is your IDE's autocomplete before AI. It doesn't just look at the character you just typed. It tracks your file's syntax tree, your import history, your variable types. It models the state of your code and suggests completions based on that model. The jump from type 1 to type 2? Memory. The agent remembers what happened and uses that to understand what's happening now. Type 3. Goal-based agents. Now we're cooking. Types 1 and 2 are reactive. They respond to the present. Type 3 is proactive. It works toward a future. You give it a goal, and it figures out the steps to get there. This is where AI gets interesting for developers. Think of a GPS navigation system. You don't tell it turn left, turn right, turn left. You say get me to the airport, and it plans. It evaluates multiple routes, considers traffic, and picks the best path. If there's a roadblock, it replans. In 2026, Claude Code's planning mode is a goal-based agent. You say, add authentication to my app. You don't tell it which files to edit. It analyzes your codebase, identifies what needs to change, creates a step-by-step plan, and executes. The goal is yours. The plan is the agent's. The big unlock? Search and planning. The agent can explore possible futures and pick the best one. Type 4. Utility-based agents. And this is where it gets wild, because up to now, agents just wanted to reach a goal. They didn't care how. A goal-based agent finds a path. A utility-based agent finds the best path. It assigns a score, a utility value, to every possible outcome, and it picks the one with the highest score. Think about it like this. You're booking a flight. A goal-based agent finds you a flight to Tokyo. Done. A utility-based agent finds you a flight to Tokyo that optimizes for price, departure time, airline reputation, layover duration, and seat comfort, all at once. It's not just reaching the goal, it's maximizing happiness along the way. In the real world, every recommendation engine is a utility-based agent. Netflix doesn't just find you a movie, it scores every movie on your probability of watching, your mood, what's trending, and what keeps you subscribed. Highest utility wins. For developers building AI products in 2026, this is the type that makes your product feel smart. Not just functional, actually intelligent. But here's where agents stop being tools and start being teammates. Because the next three types, they learn, they delegate, and they collaborate. Type 5. Learning agents. Everything before this was static. The agent was as smart on day 1000 as it was on day 1. Learning agents break that rule. They have 4 components. A performance element, that's the agent doing its job. A critic that evaluates how well it did. A learning element that modifies behavior based on the critic's feedback. And a problem generator that suggests new experiences to learn from. The best real-world example? GitHub Copilot. When it first launched in 2022, it suggested code completions based purely on its training data. By 2026, it learns from your code base, your coding style, your acceptance and rejection patterns. Every time you accept a suggestion, that's the critic saying good. Every time you dismiss one, that's bad. The learning element adjusts. Over time, Copilot gets personalized to you, and that's the unlock. Learning agents don't just follow your rules. They discover better rules on their own. Type 6. Hierarchical agents. Now we're building organizations. A hierarchical agent isn't one agent. It's a tiered system where higher-level agents break down complex tasks and delegate them to lower-level specialists. Think of it like a tech company. The CEO doesn't write code. The CEO says, ship the new feature. The VP of engineering breaks that into front-end, back-end, and infrastructure. Each team lead breaks their piece into individual tasks. Each developer executes. That's a hierarchical agent system. In 2026, this is exactly how Devin works. You tell Devin, build me a landing page with a contact form. The top-level planner decomposes it. One subagent handles the HTML structure. Another handles CSS styling. Another writes the form validation. Another runs the tests. Each subagent is specialized. Each reports back to its supervisor. If the test agent finds a bug, it escalates to the planner, who reassigns the task. OpenAI's Codex does the same thing. It spawns parallel subagents that work on different parts of your codebase simultaneously. The power? Divide and conquer at scale. The risk? If the top-level planner misunderstands the goal, the entire hierarchy executes the wrong plan, confidently. Type 7. Multi-agent systems. The final form. This isn't one agent with subagents. This is multiple independent agents, each with their own goals, their own models, their own strategies, collaborating to solve problems no single agent could handle. In hierarchical systems, there's a boss. In multi-agent systems, there are equals. Think of it like an open-source project. No one's in charge. A designer submits a UI mockup. A front-end dev implements it. A back-end dev builds the API. A reviewer catches bugs. They communicate through pull requests, a shared protocol. No central planner, just agents with shared goals and communication channels. In 2026, this is OpenClaw. You spin up multiple AI agents, one connected to Claude, another to GPT, another to a local model, and they negotiate, delegate, and collaborate through WhatsApp or Telegram. Windsurf's parallel agents are multi-agent, 5 independent agents working on 5 different bugs simultaneously in 5 separate Git branches. Even Claude Code channels is moving toward this. Your phone sends a task, Claude on your laptop executes it, and a review agent checks the output. 3 agents, 3 environments, 1 result. And here's the thing, every one of those multi-agent systems, it's built from the 6 types we just covered. The planner agent inside OpenClaw is type 3. The learning component is type 5. The delegation structure is type 6. Multi-agent systems are not a separate thing. They're a composition of everything. So here's your complete map. All 7 types organized by complexity and capability. At the bottom, simple reflex agents. Fast, cheap, predictable. Perfect for rule-based automations like linting, CI pipelines, and input validation. One level up, model-based agents. Add internal state. Use them when context matters. Smart thermostats, syntax-aware autocomplete, monitoring dashboards. Next, goal-based agents. Add planning for any multi-step workflow, code generation, trip booking, project management. Then utility-based agents. Add optimization. When you need the best outcome, not just any outcome. Recommendations, resource allocation, A/B testing. Learning agents, add adaptation. When the system must improve over time, personalize coding assistance, fraud detection, adaptive UIs. Hierarchical agents, add delegation. When the task is too big for one agent, autonomous coding platforms, enterprise workflows, complex deployments, and multi-agent systems. Add collaboration. When you need diverse expertise working together, AI development teams, distributed systems, autonomous organizations. Save this chart, pin it. It's the only decision framework you need for building AI agents. That's the foundation. 7 types, 1 mental model. And now you can look at any AI product, Claude Code, ChatGPT, Copilot, OpenClaw, Devin, and immediately understand what type of agent it is and why it was built that way. But knowing the types is step 1. Step 2 is building with them. In the next video, I'm going to take the 4 most important design patterns, tool use, agentic RAG, planning, and multi-agent, and show you how to implement each one from scratch. If you want to go from understanding agents to building them, subscribe. I'll see you in that one.